All right, hello everyone. Welcome to our next unit where we'll be talking about learning and the ways on how we learn. So for our first lesson for this unit, we're going to look at learning and classical conditioning. So our objectives and standards to describe classical conditioning and analyze responses to classical conditioning in terms of learning. And take a moment there to please look over the standards. And our desired result, how does classical conditioning help with learning? So that's our focus point for today. Have some vocabulary for you. Classical conditioning is learning. It's a learning procedure by which associations are made between a neutral stimulus and an unconditioned stimulus. And there's a couple of vocabulary here. We're going to go over them. They're a little confusing here. I understand the definitions may be, but they'll make more sense as we go through the lesson. So don't worry about that if you're a little confused for a minute. Neutral stimulus is a stimulus that does not initially cause any part of an unconditioned response. An unconditioned stimulus, or the US, an event that elicits a certain predictable response without previous training. An unconditioned response, or the UR, is an automatic or natural response by an organism to a stimulus. Conditioned stimulus, or CS, is a once neutral event that elicits a response after a period of training in which it has been paired with an unconditioned stimulus. A conditioned response, or the CR, is a learned reaction to a conditioned stimulus. Generalization is a response that is similar to a range of stimuli. Discrimination, ability to respond differently to similar but distinct stimuli. And extinction, a gradual disappearance of a conditioned response when the conditioned stimulus is repeatedly presented without the unconditioned stimulus. Again, I understand those words may be confusing. They may seem very confusing right now. That's okay. We're going to go over them in a little more clear understanding here in a minute. So Pavlov and cognitive learning. So Ivan Pavlov was a Russian psychologist who called this type of learning conditioning. For classical conditioning, an animal or person's old response is attached to a new stimulus. And this is just one example of learning of what we call cognitive learning. Now, Pavlov never intended or never expected to discover this type of learning. He was actually studying how a dog's stomach prepares to digest food when something is placed in its mouth. And instead, Pavlov recognized that he was learning about a different style of learning as well. So I have a picture here, and we're going to go over these number by number. Okay, so here was his experiment. So Pavlov discovered that the sight or smell of food could make a hungry dog salivate or kind of, drool. So he decided to perform some experiments to investigate what was occurring. Now, what Pavlov would do is he would place meat powder on the dog's tongue. And this would make the dog obviously hungry, or show the dog food, and it made the dog salivate like you see in picture number 1 here. Okay, that's a natural response. The dog sees food, it's going to obviously get excited, maybe drool a little bit. And then Pavlov did for number 2 is he would ring a tuning fork. You can see that there's no response by the dog, right? The dog kind of just sits there, maybe listens to it, whatever. This shows a bell, but Pavlov used a tuning fork, but same type of idea here. The dog does not respond to the tuning fork by salivating, right? Number 3 here, Pavlov would then ring the tuning fork and show the dog the food at the same time, and he did this a couple of times to get this in the dog's mind. So the dog would begin to salivate when it saw the food and heard the tuning fork at the same time. So finally, then Pavlov, eventually for number 4 here, took away the food, and anytime Pavlov rang the tuning fork, the dog would eventually just begin to salivate because it just connected or conditioned that the ringing of the tuning fork would bring about food. So that was the experiment that Pavlov began, and this is how he began to discover classical conditioning. There are some major parts of classical conditioning that are important to the process. Okay, we're going to go over these a little bit. The first one is what we call the neutral stimulus. The neutral stimulus is a stimulus that does not typically cause a response. In Pavlov's experiment with the dog, this example would be the tuning fork. Typically, like we said, with the tuning fork, the dog does not respond to that. The dog may lift its ears or whatever, may look at it funny, but it doesn't make the dog salivate, it doesn't make the dog do something crazy. The unconditioned stimulus, or the UCS, is an event that leads to a predictable response without training. In Pavlov's case, this would be the food. Showing a dog food, or a cat, or any other living creature food sometimes makes that creature react. So when Pavlov showed the dog the food, the dog obviously got excited, it began to salivate, it began to drool. So the unconditioned stimulus is something that we know is going to cause something to respond in a certain way that we predict. Again, imagine a dog getting excited about food. The unconditioned response, or the UCR, is a reaction that occurs when the unconditioned stimulus is presented in another way. So this would be, these two are tied together, okay? I'm going to draw arrows here, tied together. This would be the salivation. So again, the stimulus is the food. We expect the food to cause some type of response. I'm going to draw an arrow here. We expect the food to create some type of response, okay, a stimulus or an event. And then the event, or the response, is the reaction. The reaction is the drooling, is the salivation. Okay, so we know that these two are tied together. Think UCS, UCR, connected, tied together. A conditioned stimulus is a neutral event that, after training, leads to a response. Okay? For example, in Pavlov's example again with the dog, the salivation at the sound of the tuning fork and the food. Okay? So Pavlov took the tuning fork and the food, showed them together, rang them together at the same time, showed them to the dog. This was an event that caused the dog to salivate. So now we have the tuning fork and the food, which causes the dog to react. The conditioned response is a learned reaction, okay? So this is something that the animal then learns. So it's a learned reaction to the conditioned stimulus. So again, the ringing of the tuning fork with the food. So eventually, as Pavlov did, when he began to ring the tuning fork without showing the food, the dog began to salivate again, even without seeing the food. Okay, so I know we spent a little bit of time on that, but that's very important to understand these terms and how they are connected to classical conditioning. There's also things involved with learning that Pavlov discovered without these definitions. Okay, so learning and acquisition. The acquisition of a classically conditioned response gradually occurs I put that twice there, sorry. Gradually occurs gradually. But what this means basically is that it takes time. Okay, so you can't just show, like Pavlov found, you can't just ring a tuning fork, without the food one time and expect the dog to react. This experiment, or the response, needs to be done a couple of times before something will react to it. Each pairing of the conditioned stimulus, the CS, or the unconditioned stimulus, the unconditioned stimulus, UCS, and the conditioned response, the CR, is strengthened. So again, just over time, these three things will grow and strengthen. For example, the more the tuning fork was paired with the food, the more the tone brought about salivation by the dog. Okay, so remember that. So again, two things here, boom, boom, this is what we're talking about. Okay? Each time you do it, it'll bring about a more higher result. Timing of the association between the conditioned stimulus, such as the tuning fork, and the unconditioned stimulus, the food, can also impact learning. So what Ivan Pavlov found out is that it's important to pair these two together, or show them right before each other. Okay, so example, you don't want to ring the tuning fork and then bring the food out 10 minutes later. You want to ring the tuning fork and then immediately show the food. Okay, it doesn't really work if you ring the tuning fork and then sit down for 20 minutes and then try and show the dog the food. The dog's not going to remember. So it needs to be paired pretty much immediately. And that's how learning is too. During the same extent of experiments, Pavlov also explored the process of what we know as generalization and discrimination. Okay? The process of generalization occurs when an animal responds to a second stimulus that is similar to the original conditioned stimulus without prior training with the other stimulus. You might be saying, whoa, that's confusing. Let's talk about it. Pavlov tried his experiment with the food with an oval and a circle. Okay, so instead of bringing a tuning fork, he showed an oval and a circle with food. So he would show the circle with the food to make the dog salivate. Now, and the dog would salivate. The dog would get excited, blah, 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 blah. Same thing as the tuning fork. But what he also found out is that the dog would salivate when it saw the oval as well. So the dog is making a connection between these two shapes because a circle and an oval are similar in shape and size. So the dog could not detect the difference. So what Pavlov does is he convinces the dog to salivate only when it saw the circle with the food instead of pairing the oval with the food. So again, if Pavlov showed the dog the circle and the food, the dog would salivate, and then he would just begin to show the oval without the food, and again the dog would kind of discriminate. Okay, so he would begin to understand that, I don't need to salivate at the oval, I only salivate at the circle with the food. That brings us to our next point, which is called discrimination. Discrimination is the ability to respond differently to different stimuli. Put an example up here. That's why I have Mr. Tooth there. For example, sometimes, or maybe you yourself, you have people that have a fearful reaction at the sound of a dentist drill. And many people do. I myself do too. Some people do. But we may begin to generalize this, just like the dog did with the circle and the oval, and say anytime we hear another drill, maybe we hear, your dad working in the garage, or, you hear your dad working in the garage with a drill, and you begin to get kind of nervous. So if you've heard a dentist drill, but you hear another drill, it's not the same type of drill, but any drill sounds make you very nervous and fearful. But eventually, you may be able to discriminate between the sound of different drills and the dentist drill. So then, again, you might be nervous in the beginning, but then you're eventually over time going to differentiate and say, hey, if my dad's working in the garage, or if there's a construction going on outside my house, and if I hear a drill, I don't have to get fearful because I know that's not a dentist drill. This is another process of learning, is generalization and discrimination. Now, just like any other behavior, classically conditioned responses are subject to change. Ivan Pavlov discovered that if he stopped presenting food after the sound of the tuning fork, the dog would not respond. So again, even though he trained the dog that when he rang a tuning fork and then the food came, eventually over time, if he just began to ring the tuning fork, now yes, the dog may salivate a couple of times, but if he went back to the original way of just ringing the tuning fork and not showing food, the dog would not react to the tuning fork anymore. If he repeated sounding the tuning fork without providing food, the dog would stop reacting together with salivation. He called this effect extinction. This is when the conditioned response gradually dies out. So again, we've had the conditioned response of the dog of reacting to the tuning fork with the food, but if we take away that food from the tuning fork, then the dog will begin to phase extinction in terms of the conditioned response. Now, the conditioned response may not go away, and it may not be unlearned, okay? So it can be extinguished, but it cannot be unlearned. It just doesn't show up as strong as it previously did, okay? Maybe a better example to connect it to humans is some people may be fearful of driving or getting into a car following an accident. Now, gradually over time, hopefully it will become easier for that person to get into a car and drive again. However, that fear can reemerge again, perhaps even months later. And this is what we know as spontaneous recovery. So again, your conditioned response can go away, but it doesn't completely go extinct, and it can come back, and that's what we call spontaneous recovery. So again, extinction and spontaneous recovery. Classical conditioning was also performed on humans. There were some experiments that were done on humans. One of these was Little Albert, was used in a conditioning experiment by John B. Watson and Rosalie Rayner in 1920. So 11-month-old Little Albert was exposed to rats, which he enjoyed. He didn't have a fear of them. He enjoyed them. When he saw a rat, he didn't seem to have a negative reaction to them. But then they would show him a rat, and they would strike a steel bar with a hammer, and it made, a pretty. If you ever heard steel struck with a hammer, it's not a pleasant sound. So this began to make little Albert fearful every time he saw a rat. So again, every time that he saw a rat, they took away the sound, he would become fearful even without that sound being heard. Now, some said this experiment was unethical, since little Albert was shown to fear things he had never been exposed to, and making someone afraid of something that they've never had a negative reaction to, that might be unethical. There was another experiment in the 1930s. O. Hobart Maurer and Molly Maurer developed a way to prevent children from bedwetting using classical conditioning. The reason that many children wet their bed is because they don't realize they have a full bladder when they go to bed. So how do we fix that? We try to install classical conditioning to make children realize that they should go to the bathroom before they go to bed. And what they did was they developed a device known as a bell and pad. And this was two metallic sheets with small holes in it that were wired to a battery run alarm. So if a sleeping child was laying in the bed with the sheets and they began to maybe have a little bit of an accident and they moistened the sheets, the circuit would close and the alarm would go off. This would cause children to obviously awake and tell them to use the bathroom. Eventually they took this away and children began to realize that, oh, I have a full bladder. I don't want that alarm to go off. I'll go to the bathroom. So this was just another way that we can use classical conditioning in terms of human behavior. So learning and taste. Animals can also develop changes in terms of taste in relationship to learning. This is known as taste aversion. So imagine if you eat a food that you've never tasted before, and then you become very ill, such as, maybe you've tried snails, or I know my sister got ill one time after eating chicken parmesan, so now she can't stand the smell or taste of chicken parmesan because she got sick from it one time. So chances are, I should say chances, not changes, chances are, you will be very unlikely to eat or see that food again without becoming somewhat nauseous. So this is taste aversion and also involved in learning as well. So I know it's a long lesson. We're going to wrap up here. A summary of classical conditioning. Learning in classical conditioning can help humans and other animals predict what is going to happen. Again, imagine the bedwetting. Imagine, driving in a car after being in an accident. Classical conditioning may also be helpful in preparing for survival, such as finding food or protection from harm. Example again, parents may shout at their children not to go near an electrical outlet. Eventually the child will not go near the electrical outlet even without the parent shouting, because they don't want that negative reaction. It's also an example of what we know as behaviorist theory, okay, which is an attempt to understand observable stimuli and responses. And classical conditioning elicits a response by a stimulus which did not occur before, and the likelihood the response will occur again. All right, so I thank you for sticking with me on this. I know some might be a little difficult. If you have questions about it or you're confused, please let me know. Try your best on the questions, and hopefully we'll talk to you guys soon.